This digitization is accomplished by a building block of modern electronic systems called the analog to digital converter, A/D or ADC. It takes an analog input, and for each input observation, it gives the n-bit digital output. The higher the value of n, the better the resolution and lesser the error of quantization, that is, the difference between the actual analog sample value and the digitized value. Here is a look at a binary digital signal discretized from an analog signal. It may seem like a loss that a signal magnitude of high resolution is reduced to a single digit. But the trade-off with noise immunity makes up for it. Besides, choosing a higher number for n can also improve resolution at the expense of cost. Apart from noise immunity, digital circuits are also preferred to analog because they are simpler to design and provide more signal processing functions than the analog ones. They are also sometimes more economic. More and more of the signal processing functions are thus performed digitally. However, analog circuits still have their use, and many electronic systems include both analog and digital parts. Besides, any digital device needs an analog interface to interact with the real world. Digital signals having more than two values to represent a digit are also used sometimes. The two-level representation is known as Boolean logic, and the more than two-level one is known as multi-level logic.